Hello everyone, I'm Phong. I'm a junior at Ho Chi Minh City University of Technology and Education. My major is mechanical engineering technology. Today, I would like to present a research paper with the topic of design of a low-cost miniature robot to assist the COVID-19 nasopharyngeal swab sampling. Below is some information of the research paper in blue, author, nation, presenter, student ID, and Instructor. This presentation is for part 1, Introduction, part 2, Method, part 3, Result, part 4, Conclusion, and now we come to part 1, Introduction. The global outbreak of novel coronavirus as pneumonia caused by the coronavirus disease 2019 has increased rapidly. Collection of specimens from the survey of the respiratory mucosa with nasopharyngeal or oropharyngeal swab are effective way for the diagnosis and screening. During the conventional manually controlled swab sampling, medical staff are uh, inevitably in flow contact with the such patient posing a high risk of cross infection. The operating skill and physiological state of medical worker may also affect the accuracy and quality of the result of swab collection. So, there was a status and be always swapping which remote operation capability may reduce the risk of infection and admin summary of staff for all the staff. The robot consists of next step robot arm for motion control and binocular endoscope for visualization. Next is the part 2 method. A. Design concept. The robot in blue and the to degree of freedom DOF and investor figure 2. For student the swap and generate 6 DOF partial arm for the global positioning. The robot in individual structure upload easy as testing and detaching operation between the swap and the swap ripper then can be performed by either the patient or the on-site help. Professional masking the collection conventionally and post component restartable. The overall size of the two DOF and investor is 150 city 40. The movement of the two DOF robust and investor is so in figure 3 with the motion of the prismatic and the rotation zone demonstrate. The overall size of the swap paper is 33 bytes. Next, B. Hardware and software implementation. Assist DOF basic for global positioning and insertion angle adjustment. The basic arm has a global revolution to machining to adjust backward, forward, and up-down movement and a tight zone working together with a bond zone to find standard angulation of the and investor the insertion angle of the swab. The setup of the 6 DOF passive arm and the 2 DOF active and investor is shown in figure 4. Additionally, a microcontroller MCU, which is power cell and two-step motor driver were uncivilized in the design. The electron IC setup is shown in figure 4. The system is powered by a regular 9.3 ampere power supply, which can be directly plugged into the power cell. With the Wi-Fi function of the MCU, we developed a mobile phone-based user interface UI using the Blink software. This is the Blink software, figure 5. Next, C, set picture, motor current limit and the maximum page plot. The maximum value of current limit can be adjusted by setting the reference pin, and the motor maximum torque is proportional to ampere turn. The fixture limit the maximum uploadable port when the swab is in contact with the patient. Software setting. Evaluate watchdog between the microcontroller and the pin software. Finally, intrinsic feature. The lightweight design intrinsically reduces the risk when using the robot because the patient can easily move the robot away by pushing the passive arm. Next, D. Finite element analysis of the swab gripper. Apply the displacement performance of the diffraction beam of the swab gripper when the swab is subjected to external force. Next, factory result. A. Spot calibration. The error of the measured sample is 0.24 at or sub 0.16.8. The root means where error was found to be 0.77 Newton. B. Quantum and animal experiment. Spot average equal 0.35 at or sub 0.58 Newton and 0.68 at or sub 0.64 Newton, while the spot mass were 2.43 and 2.61 Newton for the quantum at pitch noise, respectively. Spot mass were within the page flow of the robot and the detectable brain of the customer sensor. And B. Quantum and animal experiment. Conclusion. Finally, conclusion. The robots can be much easily using 3D printer techniques that is together with other HTTP commonly used component on the market. The robot is intended to be used in a simple way by assembling different pieces together and controlling from the mobile app. It is concluded as mesh for where below the space below of the robot within the detectable brand of the sensing ripper and had a similar brand and brand when tested using different facility. My presentation has come to an end. Thank you for listening. Using the presentation process, there will be message for that. Thank you.